Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this video, we are going to be attempting a repair on this electrical plug tester. We're also going to do a modification to this compressed air tank, and we'll take a look at this Lego design I devised myself. Step number one, of course, is establishing what in God's name happened to this thing. And to be completely honest with you, I don't really know. So there I was, one summer afternoon, had just finished wiring up a GFCI outlet, and I wasn't quite sure if I wired it correctly though. So boss told me to plug this tester into it, and it being worthy of note, of course, that I had used this tester before, and it worked flawlessly, no problems whatsoever. The buzzer started beeping, and the LEDs lit up. But in this case though, nothing happened. Looking on the inside, though, should tell us what really happened with this thing. And normally, just looking at a board like this, you could tell what happened based on, basically, whatever component blew up or let the smoke out, it would be cracked or there'd be a burn mark somewhere. But, looking around on this thing, I see no such thing. The one thing I do see, however, is this fuse. Getting the meter out here, set to continuity, of course. If we test across the fuse, we got no beep. Fuse is busted. So, easy fix. Just put a new fuse in there, or like stick a penny across it or something, right? Wrong! The number one first thing to do when you have a blown fuse is to check for shorts. In this case, we'd be checking between right there, that side of the fuse, and these 2 points right here, which would be our neutral and our ground. If we say check between this point right here and this point, we got nothing there and nothing there. Okay. Being that there are no shorts on the load side of the fuse, we are going to bypass the fuse to test and see if the circuit is still working. Alright, got the fuse bypassed on the thing, so we got it on a extension cord here, and it's on the other end. I don't have it plugged in yet, so we're gonna plug it in, test it out. Alright, one moment, I think I figured it out actually. Let's see here. Still nothing. Okay. That's weird. If you look at it at just the right angle, those two green LEDs look to be on. And if I turn it off and on, the green LEDs are working. I'd imagine the red LED is too, because when I was testing it, the red LED did turn on. As for this buzzer though, this right here, that doesn't seem to be working. It's a lot easier to see the LEDs working when you're inside. So there you go. This thing is at least halfway working. The next obvious step would be to replace this buzzer and replace the fuse. Seeing as though this buzzer is supposedly a rare component to find, you would end up potentially needing to modify this enclosure in order to fit the new buzzer, if you can find one that fits like this. Which raises the question, is it really even worth keeping this setup anymore? So therefore, I'm just going to leave it at that. Recently, I picked up one of these compressed air storage tanks, and I've been slowly accumulating components to build a setup which can replace one of these here hand pumps. The main problem with these hand pumps is that they are relatively inaccurate when you're trying to get the correct amount of fill in a tire especially. The problem being that you fill it up, but you never really get it filled up quite to the correct level. You usually slightly overshoot the pressure you're trying to shoot for, and so you end up having to release some pressure, which generally then you would undershoot the amount of pressure that you need, so then you have to fill it up again, and the cycle repeats. With this setup, I hope to eliminate that issue. The main thing keeping me from being able to complete this setup is a lack of way to connect this tire gauge to this air tank. So that's what I'm going to figure out right now. The main thing that I don't know is if this outlet port here is 1/4 inch MPT. Alright, so if this thread in here. So it seems like that is actually indeed 1/4 inch MPT. So what we should be able to do is, if we just get a hose that's 1/4 inch MPT, we can just thread it into that hole there, and then on the other end I have a couple of these other fittings that I can just attach to the tire gauge on that end, and then we'll be able to throw it all together and test this system out. Here is the plan. This end of this hose is going to go into here. On the other end of that hose, I'm going to have this coupling and this quick connect, and then the other end of the quick connect is going to go onto this end of the tire gauge, and then the system should be working. So, let's put it all together. Awesome! That really works. Now, desperately need some Teflon tape because this is a threaded connection, and there will be a leakage path up that thread from the inside to the outside. But just for testing purposes, I think this is good enough. So let's get some air inside this cylinder and test it out. Alright, should have all the doodads and bits hooked up in the right places. So let's turn it on, start filling it up. Alright, so we'll stop it there. It's up at around 40 psi right there, just a little bit over that. So, filling works. So let's try tire repressurization now. With the tire gauge connected to the tire, and if we start the air supply, you can see that actually it's working. And there we go. About 35 psi. And the tire. Plenty solid. That's awesome. I went through a couple of revisions of this MOC that I created, and I came up with a model that comes very close to what I was hoping to achieve. Just as an aside, the design of this is mostly based around these droid starfighters from the Star Wars series. Also, can I take a moment to appreciate how awesome these things were? The concept that a robot can be both a fighter jet and a tank all in one, and transform between the two, and just the design of this thing is just awesome. The main problem that I found with these LEGO kits, though, is that the wings are pretty limited in terms of posability, which is the main thing I wanted to mitigate with this model right here. My model achieves this greater flexibility through this component right here. The way this works is, in addition to being able to pivot in this dimension, it's also able to move back and forth like this, using this 3-hole connector right here. The wing is also posable through this connector right here. The wing assembles onto the base like so. And by repeating the design on all 4 corners and reversing it for the bottom, of course, and the other side to make sure that the geometry is correct, you end up with a design that works way better in terms of posability. An added benefit of this design is it's much easier to transform it from the walking mode to the flying mode. And when compared to this model, where the mechanism is a lot stiffer, so transforming it is a little bit more difficult. Anyways, guys, I think I'm going to wrap this video up here. I hope you enjoyed watching me ramble on about a couple of extraneous things that weren't really worth a video, but were worth a sort of mashup type video. Subscribe if you're new, hit that like button if you liked it, and I'll see you guys in the next video.